Yes, once again, I welcome you all of you the lecture series of the microcontrollers. Now, today we are going to discuss the data conversion programs in C as well as some logical operations uh, that is performed by the PIC18 by using the PIC18, nothing but the C18 program, nothing but the C program. Okay, so now see that. Let's now see the some logical operations that is performed by the PIC18 by using the C programming, C18 program. So what are the logical operations means? So AND operation, OR operation, NOT operation, XOR operation, like that. Okay, you see these operations. This is the AND operation. Now OR operation, then XOR operation, then inverter operations. The symbol that are used for the programming purpose, AND operation is like this symbol. OR operation is by using this symbol. The XOR operation we can use this symbol. For inverter operation we can use this symbol, negation symbol. Okay, so now see this. These are the some inputs. You know that what is AND operation? If two inputs are true, output is true. See this. What is the OR operation means? If any one of the input is true, output is true. See this. Any one of the input is true. Now see this. Any one of the input is true, output is true. What is XOR operation? If two inputs are false, output is also. If two inputs are same, output is also. Output is false. See this. 0, 0. Two inputs are same. 0 to 0. So output is 0. 0 to 1. Input is changes. See this. Output is 1. 1 to 0. Output input is changes from 1 to the 0. Output is 1. See this 1 1. 1 1 means here there is no changes of the input. So output is 0. You know that inverter, nothing but not operation. If it is 1, input is 1, output is 0, output is 1, input is 0. Nothing but quite opposite operations. Okay, so these logical operations that can be performed in bitwise. Okay, see this. For suppose you can write the C programming for this one. You can see this C programming. See this C programming for logical operations and AND operation, OR operation, NOT operation. C programs, then bitwise operations. For the bitwise operations, you can perform the symbol is like this. Okay, for the byte operations, you can perform the symbol is like this. On shift operations, shift right operations, shift left operations. You know that series. So these are the series. What is the output of this one? This is ANDing operation, OR operation, XOR operation, then inverter operation. So why it is? So why this 05 answer? So it is 35 0 FF. You get only the 05 is the answer. What is the meaning of this one? Now we can write it in the 3. What is the meaning of 3? 0 0 1 1 is 3. What is 5? 0 1 0 1 is 5. Then what is then all 0 0 0? This is 0. Yep, 0. F means 15. 1 1 1 1. See, what is the AND operation? What is the meaning of 1? If two inputs are 1, then one output is 1. This is 1. 0 1 0 0 0 0 0. So what is the meaning of this one? This is 0. This is 5. So we'll get the 5. Yes, verify this one. This is the 5. So likewise, similarly, you have the OR operation also. What is the meaning of OR operation here? OR operation. What is the meaning of OR operation? If any one of the input is 2, output is nothing but this is 1. Series. I write the R here. You can change the pen color. I write the R operation here. This is AND. I write the R operation here. R operation here. So if any one of the input is true, output is also 1 1 1 1 1 1. This is 0 0. So what is the meaning of this one? 1 1. I nothing but the for suppose this is the 3. This is the F. So 3F is the answer for this case. For this case, you can perform the R operation. 3F is the answer. 3F. 3F is the answer for R operation. For some, they can given the some another one, nothing but this series 0 0 0 0. zeros. What is the 4? 0 1 0 0 is the 4. Then what is 6? What is 0 1 1 0 is the 6. What is 8? 1 0 0 is the 8. See this 0 0 1 1. You know that if any one of the input is to output is a 0 1 1. See this. So this is 6. This is 8 plus 4 12. So that is C. So 6C. So likewise you will perform the some XOR operation and operation. The way they can give in the number. Okay. Then bitwise operations. Bitwise operation. You see this bitwise operation. Shift right operation, shift left operation. So see this shift left operation, shift right operation. Shift 3 times right. For suppose what is so they can give the meaning of this one. Shift. See this. Shift right 3 times. So this means shift right 4 times. This means shift left 4 times. See this. Left 4 times. Shift right. For suppose what is the 9 meaning? 1 0 0 1. It is the 9. Then what is the A? It is 10. So A means 10. So 1 0 1 0 is the 10. You can move towards right. This direction. This is right direction, right? 3 bits away. So nothing but for suppose here, this position you can move. So you can move this position onwards. 3 positions onwards. So nothing but 1. So nothing but after this positions. So this is 1. What the bits are left? 1. So 1. 1. This 3 bits you can move this into these 3 positions. What are the remaining bits? So nothing but these 3 bits is joined into these places. So yes, rotate left. Okay. So nothing but 0. So first bit is moving this one 0 0. 3 bits. So that is the way you can move this bitwise operations. Then there are some program here. They can give you some program. Run the following program and simulator with examine the results. So some port A you can make the port A as output port. Then port B is output port. Sorry. At the same time port C is also output port. Port D is also output port. Then AND operation. You know that R operation, XOR operation, inverter operation, shift operation. You know that very well. What is AND operation? Same simply they can give. You write the programming is like simply port B, nothing but output port. You can move the values 35 as well as 0F. What is the answer for this one? I think we are already done that one. 35 0. What is the answer for this one? I think 05 is the answer. Yes, they can give 05 is the answer. For this one, 05 is the answer. So likewise, you can perform the another operations. So again, see this, the write C18 program to toggle all the bits of port B and port C continuously with the 250 seconds delay. So for the delay, whenever you are using the delay, on that time you can use the ms delay command here. So ms delay. So this is the PIC 18 F4 is nothing but you know that what is that one. While writing this one, this will call all the libraries that is available in this PIC 18 controller, PIC 18 F458. So ms delay unsigned it. Then this is the main program. So what we can perform here, we can toggle all the bits of bit 18 bits, port B, port C. You know that these are the 8-bit ports. These are the 8-bit ports. Port B as well as port C is the 8-bit ports. So you can make that ports as the output port. See this. So you can send any of the values, not only these values. Remember, you can send any of the values to port B, port C. With what is the time delay? 250 milliseconds time delay, and you can toggle that one. You can continuously change that values, bit values. For suppose for the port B, I can send the values like this. For suppose port B, I can send the values 1 2 3 4 5 6 7 1 2 3 4 5 6 7 8 bits. Port B. Similarly, we have the port C also. Port B. For suppose I 0 0 0 1 1 0 0 1 port B. Likewise, you can also see the port C also. whatever the values. So not only this values, I can take some different values. So for suppose I will take this value. I can toggle, you can toggle means you can continuously change that values. Nothing but 0 is 1, 1 is 0. How to change that values? You can simply by performing the NOT operation. Performing the NOT operation. So that's why you can perform series. This is the NOT operation. You can perform the NOT operation. So 1 is 0, 0 is 1. Series. For performing this one, continuously toggling means continuously changing that values. 0, 1, 1, 0, 0, 1, 1, 0 is the port B. Likewise, port C also. What time delay they can consider? 250 milliseconds time delay can consider series. That's why. So continuously with continuous of how much time series? So see, I integer I values and j values. So nothing but these are the port B and port C values. How much time? 250 milliseconds time. So that is a program. Ready? Yes. So again the same program. So right say it open to all the bits of port B, port C, and port D. With 250 milliseconds, use the XR operation. Simply XR operation. So port B, port C, port D. So see this output port. You can take any of the values. Remember, any of the values with the same values. Same values. At some cases, different values are series. Series 2 values you can consider because you can compare the 2 bits for XR operands. A, B, A, XR, XR, B. This is the 0, 0 is 0, 1, 0 is 1, 0, 1 is 1, 1, 1 is 0. This is the table for this one. So series. This is the table for this one. XR operation. Port B, port C, port D. 3 ports they can give. Okay, so you can compare these values into the series. Port B to the FF value, port C to the FF value, port D to the FF value. So remember, so now series any of the port value series. You can compare any of the values to the any of the values. You must have the input A and input B. Series. This is for suppose input A. This is input B. Simply. So this for port C also. This is input A. This is input B. For port D also. This is input A. This is input B. Any of the values you can compare. So for performing the XR operation, you must have the 2 inputs A and B. See this. If this is one input and this is the another input. Remember, you can take any of the values here also. You are not fixed these values. Take any. For suppose they can consider 3 values also, or 3 6 values. Whatever the value you can take, or not only this FF value, you can take any of the value. So AA value also, BB value also, or 50 values also. What are the values you can test? Okay. Again, write the C program to get bit RB0 to send RC7 after inverting it. Inverting means you can changing from positive to the negative, negative to the positive, or true to the false, false to the true. So you can send the RB0 nothing but port B bit. So bitwise operation. You know that for data, you know that operations you can perform in 2 ways: bitwise as well as bytewise. They can take the bit RB0 as the output series RB0. So you can define in bit port B bits, then port C bit. See this port C bit, port B as well as port C bit. So you can make that port B to get RB bit. Getting means input bit. Sorry. So port B can make it as input bit. Port C can make it as output port. So port B bit you can invert into the port C. Send into the port C. See this output bit is inverting into the input bit. So whatever, if it is 1, it is 0. Or 0, it is 1. Simple program. Okay, so this is the way you can perform the logical operations. Okay, then you can see the data conversion operations or data conversions in C. How this data conversions is performed by the microcontroller, PIC microcontroller. How the data conversion is done. Data conversion means here packed bit is BCD to the unpacked BCD numbers, some BCD number to the ASCII number conversion. That is the way. Data, you can convert the data from one form to the another form. Data conversion. See this, data conversion. You can convert the data from one form to the another. Okay, so that you can call it as the data conversion operation. Okay, the next one we can see this. Remember how to convert this operations, how to convert this microprocessor to convert from one form of data to the another form. Okay, what is BCD? You know that BCD is nothing but the binary coded decimal. Binary coded decimal. You know that ASCII. For each and every decimal number, microprocessor or microcontroller, it has some ASCII number. For suppose 0 to the 9 number, for suppose. For each number 0, 1, 2, 3, 4, 5, 6, each number in decimal, okay, in decimal format. So it is assigned to the some ASCII number, for nothing but at the rate number or one number or some hash number, some like that number, some dots or whatever it may be, some numbers they can assign. So you can convert some this number to the this format, this format to the this format. How it is done? That is done by using this data conversion operations by writing some C programs. Now see this. See this. You know, in the keyboard you press. You know that this numbers, decimal number 0 to the 9 numbers. In ASCII format, this is 30. In 1 you can nothing but 31. 2 is 32. 3 is 33. 4 is 34. So on, like this. So for decimal to the ASCII conversion is like this. Again, some decimal to the binary conversion. You know that binary conversion. Then binary to the decimal to the some unpacked BCD. You know that what is unpacked BCD? Unpacked BCD means here. So two sets, for suppose up to the 9 you will represent the number 0 to the 9 numbers only can represent up to the 9. Up to in the unpacked BCD numbers, you have to represent only the 9 numbers only. See this, up to the 9 numbers only. A, it is not possible to represent. A means here 10. I think 2 numbers are there. Only single digit numbers it is going to represent. Two digit numbers it is not going to represent. Up to the, so that's why up to the 9 numbers you are going to represent. So that number is 0, 9, up to the 9 numbers. Okay. So for suppose if it is 2, for suppose 0 A, in that what is A means here 10, 0, 1, 0. It is not possible to represent 10 number. Okay. So only 2 sets is possible. See this, how many sets are 1? This is set 1, this is set 2. 2 sets are possible. If you can represent 10 in front, you must represent 0. So that is 3 sets. It is not possible. So in the BCD formats, you can call these numbers as the illegal codes also for binary addition, subtraction operations, BCD addition, subtraction operations. So that more than that number, 9 number. So on that time you can add the 0110 for correcting that one. That you can call it as the illegal codes or whatever it may. So these are the this number to the this number conversion. See this binary numbers. You know that binary numbers. This is 3. This is 0 value. So this is, see this. This is 3. This is 9 value. 3 9 value. See this 3 9 value. This is a binary value. So convert some packed BCD to the ASCII conversion. Packed BCD 0 to 9 to the unpacked BCD. So simply can represent, you know that a packed means, for suppose I write the 29 number. So you can form the, what is 29 number, can form the 8421 code. So 8421. For this code, you can only represent the 50 numbers only. I can represent the 16. 16 plus 8 plus how much we will able to represent? So 16 plus 8 plus 4 plus 2 plus 1. So up to 31 number you can represent. See this. 16 number. Then what is the code for this one? This is 0. I mean 29 number. How to represent 29 number? 29 number. 8421 code after 16, then after 32. So no need to represent this 32 because so the considered number, you can see this considered number is less than this number. You have no need to represent this. The considered number is below this number, then only you can represent this code. Since 29 is the when compared to 29, 32 is the more number. So we need number. So this one. So 16 plus, see this. 16 by 8 is 24. 24 plus 4 is how much? Plus 4 is 28. See this, sorry. So this is 0. This is 1. See this. 16 plus, see this number. 16 plus 8 plus 4 plus 1. This is 29. See this. This is the total. This is the number we will represent. In between, in front, you can represent the for 0 zeros also. So for unpacked format, you know that for unpacked format, what is the unpacked format? It represents 2 separately, it represents 9 separately. See this. 2 separately, 9 separately. You see this in ASCII format. How to convert this ASCII? What is the code of 2? 2 code is 32. Remember ASCII format. See this. 2 code is 32. Then next number 9 code is 39. See this. 9 code is 39. See this 39. So it represents this way. 3. This is 3. This is 2. Unpacked vehicle represents unpacked. 4 bits. Remember, you represents 4 bits. This is 3. This is 2. Remember, this is 3. This is 2. You need not to confuse this one. This is 3. This is 9. You need not to confuse. Very easy to write. So these all are zeros. This is 0. This is 2. Remember, you need not to confuse that one. Simply can form the 8421 code. 0. This is 9. Or you can also this is 2 and this is 9. 2 9. But here 2 separate categories. See this, how many bits here they require here. So this way also you can represent the number. See this way also. This 1 1 1 0 1 is also 29. So in BCD format you represent separate numbers. See this 2 9. What is unpacked means here? So you can, so this is 8 bits. This is also 8 bit. In packed BCD, total 8 bits format we represent this one. See this. In ASCII also, these are the 8 bits. These are the 8 bits. Remember, that is this is the difference. So this way also you can represent this. This is also the total value, 29 value. Okay. See this in 4 key 4 is 3 4. You can simply add the 3 in front of the decimal numbers. See. Unpacked BCD. See this, these 4 numbers. See this 4 numbers is 0. This is the 4. This is the 4. This is the 0. So this is 0 4. Again, this is the 0. These are the 7. In ASCII in packed BCD, this is unpacked in packed BCD. So you can represent, you can combine these numbers. It is 47. Nothing but this is 4. This is the 7. So see this 4 7. Key, you know that key is 4 7. So you can represent 4 and 7. See this. You can add the 4 and 7. That is the 47. Pack. You can pack it that. Nothing but combine the numbers. You can combine the numbers. This is unpacked. In unpacked way, this is 4 is separate, 7 is different. In packed way, you can combine these 2 numbers. but you can represent in 8-bit format. But this 4 is 8-bit format in unpacked, this 7 is in 8-bit format in unpacked. But this 4-7 is represented in packed in 8-bit format. That is the difference. See this, in packed format, you can represent the 8-bit format. In unpacked format, each digit you can represent the 8-bit format. So in packed format, so all the numbers you can represent in the 8-bit only, because our PIC 18 is the 8-bit format. So you can write some program. So you can convert packed BCD. What is the number? 29. So nothing 0, 0, 1, 0. 1, 0, 0, 1 is the number. This is 2. This is 9. See this. This all the bits you can represent in the 8 bits only. Remember, 8 bits only. But in unpacked, you represent 02 is 8-bit format, 09 is 8-bit. So 0, 0, 0, 0, 0, 0, 1, 0, 0, 0, 0, 0, 1, 0, 0, 1. See this. This is 8 bits. These are 8 bits. See this. This is packed. This is packed. See this. This is unpacked. I hope you understand what is the difference between packed and unpacked. The code for representing both the 8421 code. So 8421 code is same. 8421, 16, 32, 64, that is same. But in packed, any number you can represent within this 8 bits, if it possible. Remember, at the same time, in BCD format, you need not to represent the number ABCDs. Remember, in BCD, that may be a packed or unpacked. That numbers are exist only the 0 to 9 numbers. Remember. Okay, only 0 to 9 numbers are. For suppose they can given 0A, it is not possible to represent in 8 bits. Remember. Okay. So only BCD, it is only 0 to 9 numbers. That may be a packed or unpacked or whatever. 3, 9 or whatever it may be. For suppose they can give 3A, you are unable to represent in R2F, R2A, R2F. For suppose like this. So these numbers are not able to represent in BCD format. Whenever you can perform any operation BCD packed or unpacked BCD or whatever it may be, you must take the values from 0 to 9. For example, they cannot given the number here. You only take in the number. First, in this number, they can given in the question. But for suppose they cannot given this number in the question. On that time, you need not to take the ABCD values. You must take the values from 0 to the 9 only. You take the values in the format of ABCD in hexadecimal format. So it is not possible to convert the BCD numbers. In BCD format, the numbers exist from the 0 to the 9 numbers. So again, so the display again, what is the program? Write C18 program to convert packed BCD number to the ASCII. You know that you can so packed to the you can ASCII. How to convert this? So 3-step process. 3-step process. First of all, what is the first step? So packed to the you can convert packed to unpacked. Then second one, so unpacked to the again just two steps only, unpacked to the ASCII. So packed to the unpacked. So you can represent 2 separately, 9 separate. So what is the ASCII format of this 2? 3-2 is the ASCII format of this 2. What is the 9 format? 3-9 is the ASCII. That is the answer. But how to represent, how to write the programming for this? According to see this. A port B is for suppose they can consider see this. They can given in the port B and port C. So you can display that numbers in the port B and port. So that's why you must take that as the output ports. So you can convert this in the some byte operations only. So that's why you can take the byte my byte. What is the my byte value? Byte value 0 to 9 value. In AND operation, from here some AND operation. So AND operation. So AND operation, why can perform the AND operation here with F? AND operation with F. See this. So AND operation with F. Perform again AND operation. 29. 29. What is the 0 0 1 0 9 1 0 0 1? What is AND F? 0 0 0 1 1 1 1. AND operation. 1 0 0 0. Sorry, 1 0 0 0 0. 0. We will get the numbers 9 0 9. X is now X is here. What is the value of X here? Here 9 value. Then X R operation with the 30. X R operation with the T0. Why you can perform the 0? 30 means here 0. You can make it as a 0. See the 0. Make it ASCII number 30. Nothing but key 0 means. So what is 9? 0 0 0 0 9 1 0 0 1 9. See this 9. 9. You know that, you understand why you can perform the F. You can 0F 1 0 can separate the packet to the unpacked. For this operation you get the 9 value. For this operation you get the 2 value. See this. You can separate this packet number to the unpacked. For separating purpose you can perform 0F. For performing AND operation to the 0F you get the 9. Again from 0 to the F0 you get the 2 here. Then Y value is 0 2. Yes, see this, you can separate these two numbers. Again you can perform the just ASCII numbers. Just ASCII numbers 4 bit ports. How many bits you can rotate here? 4 bits. You can 4 bits to you can convert this one operation to the unpacked to the ASCII. Simple. For packed to the unpacked BCD conversion, just simply can perform the AND operation with the number called F. Simple. You may be convert some this more significant bit the least significant bit. Whenever you can convert the least significant bit, you can perform the 0F operation. Whenever you can convert the most significant bit to, you can divide that packet to that packet, you can perform the F0 operation. Okay. See this answer. So 3932. They can given the 29. In 29 you can convert into the 02 under 09. Then to the this is packed. It's the batch. This is unpacked. Wow. Then unpacked to the ASCII. ASCII number 02 is 32. Then 09 is 39. See this. Simple. That's why they perform the AND operation of the R operation of the X. 39. See this, X is 9. See this operation. See this, how we will get the 39. So what is the value of X? X is 9. 0 0 0. Okay. 0 9 1 0 0 1 is 9. You can perform 30. See this. This is 9 and 30. This is 9 and 30. You can perform 0 0 1 1 0 0 0 0. This is 30. Just simply, what is R operation? You can perform the R operation. What is R operation? 1 0 0 1 1 1 0 0. So this is 3. This is 9. Simply, this is converted into the ASCII. I hope you understand the logic behind this. Simple operations. Similarly, you can perform the 3 to also. So here a quite different operation. Convert ASCII digits 4, 4 and 7 unpacked BCD and display in port B. You can convert ASCII digits of 4 and 7 to packed BCD. Again same in opposite ASCII to unpacked, then to packed. So some quite opposite operation. Display port B. So you can make that port B as the output port series. So for unsigned character, you can take the 4 and 7. They can give in the question 4 and 7, but otherwise you can take any of the values from 0 to the 9. So BCD operations, remember, ASCII there are more numbers, symbols are also there. ABCD values also there in ASCII. But this, you can convert this ASCII number to the BCD. You must take the 0 to the 9. In the examination, they cannot given the 4 and 7. Then convert some ASCII number to the BCD. So ASCII numbers are ABCD is also there. Any symbols also there. A 0 to 9 numbers there. A to the Z numbers are there. Some special numbers are there. But BCD only. While performing this ASCII to the BCD conversion, you can only take the 0 to the 9 numbers. In the examination, they can add given like this. But here, in the question, they can give 4 to 7. What they can, then you can convert this into the packed means what is the answer? You will get the 47. What answer will get the 47? I hope that answer is 47. Yes, it is 4B. In the experiment, what is the answer? 47. 4 and 7 they can given separately. You can combine that two numbers, you will get the 47. Yes, series. For unpacked format, 0, 4 and 0, 7. So the ASCII format 34, 37. But simply again here, see this. What is the value of W here? 4. You can mark that into the F. You can mark the 3. See this. Unpacked number they can given 4 and 7. You can convert that 4 and 7 to the here. See this. Then see this. This is the F. So here they can get the 3, 4. I mean here they can get the 3, 7. So you can shift these numbers. Then you can R operation with the W and Z. W and Z R operation. Then you will get the 47. Simple operation. Here they can give the unpacked. So you can just convert into the packed. Here in this program, they can given unpacked. You can convert into the they can given the packed. You can convert into the unpacked and ASCII. Here in this program, they can give in the unpacked number. You can convert into the packed and by using the ASCII. Again, you have some another method is also there that you can call it as the checksum byte. Checksum byte. So what is the what steps you are going to take for performing this checksum method? So add the byte together to the drop the carries. Add the bytes together and drop the carry. Then take 2's complement of the total sum. This is the checksum byte, which become the last byte of the series. 2's complement, you can perform the 2's complement. Series 2's. So they can given some hexadecimal numbers 25, 62, 3F and 52. H, the meaning of H means hexadecimal. Remember, the meaning of H means hexadecimal. Okay, so find first one. They can give some questions. Find checksum byte, perform checksum operation to ensure the data integrity, and some second one they can give some answer here. See this. Check bytes. So you can perform the 2's complement means first you can perform the 1's complement. 1's complement is quite equivalent to the NOT operation. If it is 1, you can perform the. So how to perform the 2's complement? First of all, for suppose they can give the number 0, 0, 1, 1. You can perform the 1's complement for this number. What is 1's complement? 0, 1, 1, 0, 0 is 1's complement. For 2's complement, just add the 1 to this one. So 1, 0, 1, 1. This is the 2's complement of that. Here they can given the number 25, 62, 3F. So you can given the 25, 62, 3F. Then you will get this one. So you can drop the carry. Remember, you can drop the carry. They can given. You can drop the carry. So how much number they can given? 118. But 2-digit format only it can take. Remember, 2-digit format only it can take. So it is the 3 digits. So this we can call it as a carry. You can drop this carry. So we will perform this 18 to the 2's complement, get the E8. See this, how we will get E8. I will show that to you. 18 means 0, 0, 0, 1, 1, 0, 0, 0 is the 18. Okay, then you can perform the 1's complement first. 1, 0, sorry, 1, 1, 1, 0, 0, 1, 1, 1. Then I can perform the 2's complement here. Add the simply 1. 0 to 1, 0 to 1, 0 to 1, 1, addition operation. So again 0, 1, 0, 1. So this is E, this is 8. See this E8, you will get the answer. This is 12. 1, 0, 1, 0 is 12. 12 means here E, this is 8. That is the way you can perform the 2's. Similarly, then what is the second one? Perform the checksum operation to ensure the data integrity. Again, here, for suppose for the same problem they can give, you can drop the carry 2. This is the carry. They can drop the 2. What is the answer? 0. There is no need to perform this. So, when data is not corrupted. So, okay. Then in the second byte 62 and change it to the output checksum detection. That is third. So you can check there is a checksum method. Why you are using checksum method? For suppose you get some data from A to the B. Center A to some computer 1 to the computer 2, get the data. Some data. Whether 2 is checking sending data is correct or not. Nothing but the receiving data is correct or not. That is the purpose we are using checksum. Just for checking method. Like you can also you have the parity checker. You know the parity checker. Why you are using parity checker? For checking the the received data is correct. That is the way we are using this. That is the purpose we are using this checksum method. Okay, so different methods are there. One is the checksum method. The next one is the parity, even parity method, the odd parity method. So to check whether the received data is correct or not, that purpose we are using this checksum method. So here that performing checksum method, these are the two conditions for that. Okay, so see this in third question at the mud C. The second byte 62H has been changed to the 22. 62H is changed to the 22. So this checksum detect the error or not. See this, yes, they can give given this. They can given this one. Here, for suppose 62 they are sending 62, receiving 22. Here in the question they can ask that. So, but what answer? But you are not getting 22. 62 is changed to the 22. So you are sending which value? 62. But what value you are getting? 22. But what is the right value? 62. But you get the 22. You check whether this value is correct or not. What is the value? You get the this 1 to the 2, 62. You want the value 62, but you get the value 22. Sending to the receiver. So there is a problem with that. You get the wrong number. Here you can prove that you get the wrong number by using the checksum method. So what are the numbers they can give in 25? Then what number you will get the 22? You can add these numbers, 52 on all the numbers. See this. You can drop the series. You can drop the 1. You can drop the value of 1. That's about carry. You can drop the carry value. This is the carry. You can drop the carry. That is the first step. You can drop the carry. Yes, you can drop the carry. Then you can see the C0 to the, you will get the C0. This means, so C0, you will get the 0, 0. Then only data is correct. Data is, data is not correct. That means data is correct. The right data you can get. Here you get the C0, nothing but C0, nothing but it is not 0, 0. So see this example. See this B example. You send the 62, you get the 62 also. See this, what is the answer? You will get the 0, 0. Nothing but there is no error in this checksum. Checksum simply you can add all the numbers, you get the 0. That is the correct answer. You can add all the numbers, you get any more, instead of 0, you get any of the number, you will get the, that means that is the error. You can compare the B and C simply. You compare the B and C. B is correct number. You, for suppose you get the 62, you are also receive the 62. Because why you confidently tell that you get the same number, whatever you are sending that number. The reason behind that one, you can check that number. Simply you can add all the numbers. What are the numbers you will get? So see this. You can add all the numbers. What is the number you will get? E8. See this. E8 they also can add it. Before this number, see this. Get the 0, 0. Remember, that means you get the correct number. But here you get the 22. You can add this 22 to this remaining numbers. At the 25, 62, 3F, 52. See this. 52. You get the 0, 0 for this case also. No, on that case you told that you, so the same number you are receiving, but here it is not 0. That's right. So you are getting the some error. So for that purpose, so this is the calculation purpose. But for checking purpose, writing the program this way. So write CAD program to calculate the checksum height for the given data. Example, this example. For this example, 25, 62, 3F, 52. 4 bytes. We'll check that answer series. 25, 62, 3F, 52. So what is the process we will perform the? You make that, first of all, you can perform the 2's complement. Then once you will get the 2's complement, you can add that 2's complement result to this numbers. First of all, 2's complement. 2's complement. You can add the 2's complement result here. Then you will get the. Then we will see that answer. Whether you will get the 0, 0 correct number, or otherwise you will get the wrong series. Simple. Some unsigned character data. You see this. This is the data we will take. So by checksum can assign this value 0 to some x value. So see this can make the some port B and port C as the output port. But in the problem they cannot given which port you are taking, port B or port C or port B, whatever. So for our simplicity purpose, we are taking port B and port C. Not only that, we are also taking the port A also, port B. So this is not mandatory to take the port B and port C, but because they are not given in the problem. So you can make the port B and port C as output. See this, this is the loop for this one. This loop is runs until the x value is less than 4. Less than 4. So port C is equal to the my data x is nothing but this value. So nothing but this value is first is 0, then 1, then 3, 1. That is the condition you recognize. This is initialization, condition, and increment. For loop they can given this is initialization, condition, increment or post increment or pre increment. You know that very well. Decrement or whatever. Then sum is equal to sum plus my data x. What is some value? See this. These are the my data. What are the my data values here? 25, 62, 3F. The next value to the you can add that to the 4 times. This is 4 times. 0 is also 1 time in Microprocessors. First time, second time, 3 times, 4 times. See these 4 numbers. 1, 2, 3, 4 numbers they can add. That sum is given. That added sum. That result is going to the B. What is the sum is here? I think that sum is 118. Here in port B you have the value 118. I think see this 118. So that 118 you can drop the value 1. So that's why you can negate that value. then given the +1. So 2's complement to the 1's complement. So this 2's complement to the 1's complement you can convert. Then can given that value to the port B. So then what is the value in port B is there? Simple. That is the way you can perform the sum operations. Again, write a C program to convert this FD value. So nothing but this is the F value. Then again, this is the D value. 4 bits you can consider to decimal and display the digits on port B, ports and port D. Port B, port D, you can consider as a output. What is the value they can consider here? FD value. In a given they can. So we can divide that value into the 10. Why? You can convert that decimal to the you can convert this binary values to the decimal. So binary to the decimal. You know that how to convert this binary to the decimal or decimal to the binary conversion. You know that we can multiply by the 10. So in this process, but in quite opposite, so you can divide it by the 10. So that's why you can divide it by the 10. You know that binary to the decimal to the binary. How to convert some decimal to the binary? You know that some binary number to 8 per suppose, then 2. This is the one way you can convert some binary to the decimal. So 1 into the 10 power some value. So for suppose 0, 0, 1 value. Suppose 1 into 10 power 3 plus 1 into 0 into 10 power something like you can convert this way. You can convert some binary. So this way. Simply, you know the operations of conversion. So the way you can write the programming is same. Okay. So thank you for joining this.